Hello, everyone. My name is Brittany Carpio. I'm the Director of Awareness for the Student Union Board, and I am here to introduce our wonderful lecturer. As an expert in global warming, global health, and much more, Dr. McHugh has traveled and worked extensively around the world. As a peacemaker, researcher, and physician, she has helped organize many forums on cross-cultural global health and women's health issues. She is a coordinator for the Iowa chapter of Physicians for Social Responsibility, a founding member and former director of the University of Iowa Global Health Studies program, and also a founding member and executive committee member of the University of Iowa Center for Human Rights. Her most recent work has focused on climate change, coal, and their related threats to health. And today she is here to discuss those issues with us. Please welcome Dr. McHugh.
Thank you, Brittany. It worked. Okay. Well, I have to say I'm quite amazed to see all these students out at 6 o'clock on Monday night. You have a very persuasive syllabus and teachers here, apparently. So, and I know there's a number of other experts in the audience, so this will be very interesting interaction for me and for you. I hope we have some dialogue as part of the whole process. As Brittany said, I don't claim to be an engineer. I do claim to be a physician and a human rights worker. And I think often when we talk about climate change, when we talk about energy issues, we're often talking about economics, or we're talking about jobs, or we're talking about polar bears. And I like to bring things back to health and health rights, human rights, that kind of perspective, because I think too often it's missing in a lot of the conversations that we're having nowadays about what is going on in our environment, in our climate, and in our society in general. Holy moly. Excuse me. I'll just turn it off. It doesn't want to turn off because it's too embarrassing for me. And now my program is not responding. What? Hello. We'll try again. Start over. It's closing. That's what happens when you set up a half an hour early. You got tired of waiting, I guess. Okay, well, I'll wait for it to start up. Anyway, I started doing talks quite a few years ago now about climate change. And part of what you have to come up with eventually is focusing on what is the most important sources of climate change. And a lot of times we talk about our cars, or we talk about our light bulbs. But we often, I think, miss the forest for the trees, and we forget that burning of coal is the greatest point source for CO2 production. And so I started looking at the role of coal and its effects on our climate and on our environment. And I think coal is a particularly interesting subject because it has so many pieces to its life cycle, and we all tend, depending on where we are, to focus on that piece of the life cycle that interacts with us the most. And so here in Iowa, when we're talking about coal, we're primarily talking about, what comes out of the plants. I'm really sorry. I hate technologic challenges. It's like getting at me because, everybody thinks of coal as you flick a switch and everything works, and I'm talking against it. Where was I? Okay, I was lost in the coal plant. So anyway, there's a couple of seats up front, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, plenty. We couldn't get started anyway because the computer turned off itself, so we were just probably waiting for you. Why is it not working? The only other time I was involved in trying to give a lecture or be part of a lecture was right after we got married. My husband was supposed to give a lecture, and all the machinery shut down. And he did a very good job of talking without any of his slides, so maybe I'm going to have to do that too. It doesn't want to do anything. So anyway, we're going to try and make it up as we go. Talking about coal, I think the thing that we often don't realize is that coal has a very interesting life cycle. And when it's being mined, you have very definite health threats to the miners, to the people in the communities around it, to the water sources. And then as it's being cleaned after it's been mined, you have a lot of slurry that goes into the water and affects the water table in the surrounding communities, such that a lot of the people in the Appalachians and in other parts of the world where coal mining happens, they actually can't even use that water that's locally available water because it's so incredibly contaminated. And then you have to ship that coal to wherever it's going to be burned. And in the shipping process and in the train process, etc., you have a lot of dust that comes out of it. It's called fugitive dust. And people with respiratory problems anywhere along the line of where the coal is being shipped have a lot of respiratory problems. They know when the trains come through. They know when the shipments are happening because of the dust in the air. This is one of those times where you really wish you had somebody else who was with, and so then you get into the place where the coal is actually being burned. And we have forgotten that we get a lot of our energy from coal. And Iowa is a particularly unusual situation in that we no longer produce coal in this state, but we import it, all of it. 73% of our energy in the state comes from coal. And so we are the second highest coal importing state. And on a per capita basis, we are burning coal much more so than most states. Now let's see if we can actually do it. It's still not ready, is it? I hate that little icon. You know, some people can tell jokes. Okay. I know there's a group of you in here who are supposed to be evaluating me as a presenter. Such stress. So go to slideshow, please. View show. We want to view show. I don't want to update Adobe. View show. Yay. Okay. All right, we've all seen this page. I have yet to see that head. Anyway, so as we all know, energy obviously is essential to our daily lives. And this is a very big issue for all of us nowadays to figure out what we're going to do about energy. Fossil fuels have been producing our energy over the last 2 centuries. But curiously, we have all these very streamlined, white, wonderful mechanical devices nowadays, but they're all being fueled by that same rock that fueled the Industrial Revolution in London. And as I started to say, they bring so many hidden health costs. And these are real economic costs, too. Even though we talk about it as cheap energy, it's because the cost to our health, the cost to our environment are externalized costs. They're not part of the whole energy system. And the cost to health and cost to environment across the entire life cycle of this particular product. And one of the things I like to focus on, because I am a physician and I do teach global health, is the fact that the risks are borne primarily by the most vulnerable members of our population. Never again will I do this. It's the first time I've ever been asked to actually bring my computer, and it's the first time it's ever not behaved. Okay, I'm sorry. I'm really sorry. This has never happened to me before. I teach every day. It always works when you use the university computers for the most part. So I'm trying to remember what the next slide is. Anyway, so I wanted to go over those hidden health costs for the most part and talk about where do we go from here, and talk about how when we're facing the changing climate, when we're facing the changing environment, when we're facing scarcity of water, how are we going to put all of this together? I mean, this is, for many people, a very scary confluence of many things that are happening all simultaneously. It really does not want to work, does it? Does anybody have any idea why it won't? Any tech people? We used it the other day and it worked just fine. I have 36 slides. I'm trying to remember what they each say. Pardon? Well, it just seemed to have done that. Yeah. Oh, somehow it's up on it twice. Yeah. Ha! Thank you. Thank you. I was really starting to sweat and thinking I have to reorganize absolutely everything up front. It's really easy to change what you have to say when you're only talking to your family or to a few students that you know well, but total strangers. Anyway, so the idea is that we also often think about things as single entities. And when you're talking about air pollution or you're talking about coal, it's very hard sometimes to get focused because, in fact, we're dealing with all sorts of forms of air pollution. And the coal and the health specifics are going to be different depending on where you're at and who you're talking to. And so when we're talking about coal or other energy sources, we're also thinking about all of the other air pollutants that are out there. And, of course, a lot of us think about cars. And a lot of us here at Ames obviously think about agricultural processes. Agriculture, as we practice it today in this very industrialized mechanism, is extremely heavy on fossil fuel use, on nitrogen, on producing a lot of the particulate matter that can go and mix with the particulate matter of coal. And so all of these things are in our air, and it's really difficult sometimes to avoid them. The only thing we don't have, obviously, is volcanoes. And certainly we get a lot of molds and pollens, and as part of the climate change issue, molds and pollens are also becoming more of a concern, particularly since we've been having all this flooding. As you may or may not know from any of your history classes, or if you're taking energy classes, you understand that air pollution is more than just a nuisance. In old London, when people would see this very thick air, there was even a time when they thought it was healthy, kind of like I always like to say, like doctors used to all smoke Camels, because Camels were the most healthy cigarette out there. What you become accustomed to, you tend to take for granted and don't question it. And many in old London or old Pennsylvania or old Chicago or old Pittsburgh, took the air pollution for granted until we had several of these episodes where a very large number of people died quite suddenly with the presence of significant air pollution. And this Donora, Pennsylvania, 20 deaths, it was in a very small town, so it was a relatively large number versus the large number in London. And depending on who you read, how they look at the picture that went on in these cities, the death was actually higher because some of the people who didn't die immediately during the actual fog of all of these pollutants went on to develop severe pneumonias and respiratory problems and then died within the next couple of months. And so the deaths from air pollution have now been well documented over the years. And it has led to several efforts to clean up our air. And we've had clean air legislation and Clean Air Act and clean air amendments now since the 1950s. And as you know, there was a major difficulty just the last month or so with the Congress and the President and people in the EPA trying to tighten it down even more. And in the end, they said, no, we're not going to do it because it costs too much to the industry to eliminate yet more of their pollutants. But what they didn't talk about is the fact that as the climate is changing, we're going to have more risk of ozone days. And so that is one of the reasons we really want to begin to tighten down yet further, because things are changing and the relative impact of the air pollution is changing our risks. With the warming air, we know infectious diseases are going up. It allows for certain nasty little critters to survive and circulate more readily in the warm air. And so I think it is very important that we consider the role of government. I know nowadays it's kind of, the discourse of society is smaller government, smaller government, smaller government. But what you don't realize is without regulation, we could be going back to some of these problems that people were seeing in earlier years with air pollution, with no regulations. And even so, regardless of the ozone issue, the mercury, the lead are in these emissions as well, and we haven't really controlled them. We've done some control of the acetic gases, the sulfur and the nitrogen. Carbon monoxide is still part of the problem, and particulates remain part of the problem. And we learn more about particulates all the time. The science of the health implications of breathing in these particulates that are very, very, very small. And they cross the alveoli in the lungs and they actually get into the circulation in a way that we didn't understand. But before you get into all the health, the other thing is a lot of people want to know, what about the air, in my neighborhood or in my backyard or what have you. And the problem for all of these things is very difficult to talk on an individual level because there are very unique conditions just within, blocks and neighborhoods. And all of the data that we have, for the most part, for health implications is done on a county-wide or a statewide basis as opposed to in a neighborhood. And the conditions within every neighborhood are a little bit different. But in general, as I started to say, it is the largest point source for greenhouse gas emissions in this country. It is the largest source of mercury poisoning on the planet. In the country, I'm sorry, there are other sources of mercury poisoning. And one of the largest sources of water pollution. And as a person concerned about what's going on in the globe, as well as in this country, we have a lot of concerns about water pollution, water scarcity. When you have 7 billion on a planet that has no more water than it had when Jesus walked or when Muhammad was here or when the Buddha was here, we have to conserve our water. We cannot willy-nilly pollute it either with thermal pollution or with pollutants from the actual emissions all along the life cycle of coal. And then the other thing that I'm sure you all know, because you study this when you study about climate change, is that CO2 remains in the atmosphere for a good 100 years. There are a number of different greenhouse gases out there. They have different intensity. They have different life cycles in the atmosphere. But CO2 is the most predominant, and it's very long-lived. And what that means is that even if we stop today putting coal into our environment, it'll be about 100 years before the effects are completely seen because, what you put out yesterday and the day before and last year and the year before are still up there in the atmosphere. So this is a picture of what happens all along the life cycle of coal. And I like this picture. This is what's called mountaintop removal. I think some of you are studying that, right? At least 300 of you. This is my favorite picture. There are lots of pictures out there of mountaintop removal, but this is my favorite because it has this little house here. It gives you a sense of the scale. We are talking not about a small process. We're talking about taking an area that was a pristine forest and deforestation also are part of the climate change picture, right? and where you had pristine streams and animals and CO2 eating up being eaten by the forest, it's all been removed. And the birds and the bears and whatever. And anybody who's living down below that, their house is being rocked by the explosions that go on. Eventually everybody just leaves because it's so difficult to live there under those circumstances. And then when they clean the coal, it creates a slurry that creates this kind of water, not exactly the kind of water you want to bathe in or fish in or swim in or have running in your bathtub. And then, as I mentioned, when you ship it, it's very dusty, and so all that dust gets out into the air. And then, of course, when you burn it, it's being emitted from the tops of the stacks. Even though we have scrubbers and it's much cleaner than it was when it was being burnt in London, there's still lots of problems with it. And then the final problem, which I think increasingly we have to think about here in Iowa, is when you're done burning coal, it doesn't just disappear. It isn't all gone. It's inside those scrubbers. It's at the bottom of the stack, and it has to get taken out. And it has to be put somewhere. And now some people take it and put it into concrete. They put it into the highways. And some people take out parts of it and they use it for fertilizer. But a good portion of it goes into pits or goes into quarries or goes somewhere. If you burn something every single day, it accumulates and you have to put it somewhere. And so a bunch of these coal waste ponds are getting too big and they're breaking. And so in 2008, there was a huge break in Tennessee. I went and I met some of the people who lived around there and talked about all of this toxic sludge coming down. Again, affecting all of the animals, the wildlife in that area, obviously moving a lot of houses. And then just a couple of weeks ago, Wisconsin, one of these dump sites spilled into Lake Michigan, i.e. polluting much of the area all around them in Lake Michigan. And for us in Iowa, we have a lot of this coal ash. As I said, 73% of our energy here in the state comes from coal. And the other thing is that as a point source, it would take over 1 million cars off of the road to equal what's being put into our atmosphere from just 2 coal plants. And I made this slide just a few days ago, and then just the other night I was reading the report. I don't know how many of you follow all of this, but the latest report from the scientists involved in the IPCC have now said that we have gone way beyond even the most dire predictions in terms of CO2 being put into the atmosphere. And they're now saying the least is 5-degree increase centigrade by the century's end. And we all know that a very small change in global average temperature brings along big changes in the ecosystem. So the situation is getting quite urgent. It's kind of out of the phase of let's discuss it. It's really time to actually begin to do something. And the problem isn't just the CO2. The problem isn't just the waste. The problem is that coal in particular contains all kinds of other respiratory irritants, all kinds of toxic minerals and elements. And while both CARS and point sources are putting it out there, the coal in particular has a lot of health implications, particularly to the respiratory system, but also to premature death, to heart attacks, heart disease. Cognitive behavioral disorders are likely associated with a lot of the heavy metal deposition in our environment. And there's been a number of studies. It's hard to count exactly. And that's the reason I talked about there are other pollutants out there, obviously. But at minimum, we know that there's at least about $1 billion in health care. And we're all very worried about healthcare expenses and health insurance. And so this is part of that economic picture, that human suffering picture that we don't talk about very much when we talk about energy options. And then the list of things that are in coal is really phenomenally long. I put up a bunch of them because you're not supposed to put up too many words on one slide. But the list, depending on which chemist or which physicist or which hydrologist or geologist you read, the list has variable length from 67 to 85 different toxic compounds. And again, just like the EPA is having a great deal of difficulty monitoring and controlling ozone, there's a lot of argument out there about controlling and monitoring a lot of these other toxins as well, whether or not we're going to call them toxins. And obviously, you can be exposed to very tiny amounts of these things, and they're probably not going to have a great impact on you. The problem is that they're accumulating in the environment. So long as we continue to burn the coal, they will accumulate. And I think it's interesting to think of 134,000, almost 135,000 pounds of mercury pollution in 1 year alone. It wasn't all that long ago that doctors were always telling women to eat plenty of fish when you're pregnant because fish is so healthy and it has a lot of healthy nutrients. And now we all tell them, no, be careful what fish you eat. Tilapia are little, you can eat them. You can have a fish every few weeks depending on what size it is and what species it is. But you want to be very careful because mercury accumulates as it goes up the food chain. And it particularly accumulates in pregnant women as well. And I'm sorry you're sitting right up front when I'm talking about this. But it's quite concerning. And mercury is a neurotoxin. It's not something you want to be exposed to. I mean, in the healthcare setting, we've gotten rid of all of our mercury thermometers because somebody might have broken one and a little bead of mercury might have gotten out. And we've gotten rid of a lot of mercury, but we, for some reason, tend to overlook the fact that we're putting it into the air on a daily basis. And we're putting it into the ground in these coal ash deposits. And then something that you don't generally think about or talk about are these very, very fine particles, like I was mentioning, that get very deep into your entire respiratory system and then into your circulatory system. And if you can tell from this picture, this is a human hair. So you can get a sense of how really tiny these are. And for quite a few years, we would control the number of PM10 that people were getting into the air. But now we're finding the PM 2.5, which are even tinier still, are the ones that are the most concerned. And the more the research goes on about these particles, they are finding that they're actually associated with probably with diabetes, with Alzheimer's, with a lot of the chronic non-communicable diseases that we're all quite concerned about. In your exercise class, you learn if you eat right and you exercise right, you won't get diabetes. We know that 1/3 of Americans now are obese, and we've blamed it on junk food, and probably it's a big actor. But what we haven't considered is that when you look at a map of where the obese and the diabetics are, it equals a map of where the worst coal air pollution is as well. And so increasingly people are looking at mechanisms connecting diabetes, Alzheimer's, etc. with this kind of air pollution. And I find that to be very troubling likelihood. With regard to cardiovascular disease, that is well established. And the thing about particulates and why I was showing you all those other forms of pollution is that they commingle. So if you have a lot of coal and you have a lot of traffic and you have these confined animal facilities, which we have here in Iowa, and you have a lot of agriculture going on, they tend to commingle and create new species of these particulates. And as I mentioned, in Iowa in particular, we burn disproportionate amounts of coal. And people don't realize that. You don't think of coal when you flip on a switch. And we have some of the oldest and some of the least efficient facilities. The newer plants actually put out less emissions. But the older plants that have been grandfathered in and allowed to get by some of the regulations are found here in Iowa. And as I mentioned, not only is the coal waste, the ash that we make, of some concern to all of us, but that we actually import it. So we have more than our share that we're burning, that we're importing. And our children all live very close to these facilities. This picture that I have up here is Muscatine, for those of you who don't recognize Muscatine. But what you don't realize when you look at this picture is that we had just walked out of a school. We had just had a talk in a school about coal, and I'm standing basically on the edge of the playground to take this picture. And so this is what our kids are being exposed to all across this state. It's worse in Muscatine, it's worse in Davenport, it's worse in Clinton, it's worse in Waterloo. But to some degree, we're all, at cross winds. The predominant winds are west to east, but during the summer we have south to north, and along the river we have north to south. So there's a lot of movement of these particles. They're very small. As you know, we pick up particles on the west coast that come out of the Sahara or out of China. These little tiny particles, they don't just stay in one place. So if they're being put out all across the state, they're moving across the state. And as I mentioned, we do import it. Some of them go into lined facilities, some go into unlined. If you put this material, a very fine ash, into unlined sites, it has the potential of moving into the water. There was a report this morning about arsenic in the wells. Of course, they say we have natural arsenic here, but I don't think anybody knows whether or not any of it is related to what's coming out of the coal. But it also has all these other elements in it. In terms of here in Ames, a lot of the coal ash from this particular university is being dumped up in Waterloo, so you're not at risk there. They might be eventually. So far, the water tests okay. But I think what's important for us to remember is that the climate is changing, and that we continue to poke the environment monster or the climate monster at our own risk. This is Fort Calhoun, which is a nuclear plant along the Missouri River. Came very close to breaching in the last flood season. Very close. It was shut down for months because of this flood. And, we were hit by some very strange tornadoes this past year. We've had, 3 500-year floods in the last, in all of our lifetime, which would make us equal to 1,500 years old if that were really the case. So these are concerns. And because we do burn so much coal, and because we do have other industry, and because we do have CAFOs, and because we do have highways, we do have trains, we do have schools that are facing higher levels of toxicity than many of the other schools in this country. Ames comes out pretty good. Des Moines looks a lot worse. Waterloo looks a lot worse. Muscatine, Clinton do. But still, local Ames schools rank in the 13th to 25th percentile. If 100 is very good and 1 is very poor, Ames comes in down on the bottom half in terms of potential risk, not necessarily every day at every school, but the schools are under some risk. And part of the problem, as I mentioned, is because you can have something coming out of the coal plant here and something out of another plant there, and they mix, and their plumes may both land on the schools. We don't have any rules or regulations about siting of schools with regard to air pollution. And so you can be putting schools up where the air is not necessarily very healthful. And these are just a couple. You probably know more than I do. But no matter what you look at in terms of risky air, the City of Ames power plant comes up in the list first, second, or third. And the thing about children, you all might remember, is that you're different than adults. And maternal exposures matter. Children crawl around, they pick up things, they put them in their mouth. And they're very busy, they take a lot of risky behaviors. And their lung development is not complete when they're born. So throughout their life, the lungs, or throughout their childhood, lungs are growing and maturing. And there's been a lot of studies in areas with very polluted air that show that if children are exposed to polluted air, their lungs never do completely mature. And we're seeing much more asthma than we did 20, 30 years ago with increasing amounts of pollution. Children spend more time outside, they breathe faster, they inhale more particulates for their body weight, and they have very narrow airways. And so we see a lot of asthma in children these days. It's very difficult for them. So because I come from the health and human rights perspective, we have to remember that our children are politically powerless, that they need us to protect them, and that they deserve the right to grow up in healthy environments. And it's been shown that people living near coal-fired power plants, children or adults, experience higher asthma exacerbations, asthma deaths. And we don't know which one of anyone is the one who's going to be affected. We just know that as a population, we see these impacts. And so when I'm out talking to people, I'm talking to them as parents, as neighbors, as concerned citizens, as students who are learning to get involved in the political process, that you really have to talk to people about cause and effect, and you have to talk to people about regulation. You have to talk to people about legitimate roles of government in monitoring and responding to some of these threats. And so, you can't just stick your head in the sand if you're going to be part of a community, if you're going to be part of this earth, if you're, sharing the neighborhood, so to speak. And you can't just run away. Of course, I'm hoping some of you have some good ideas. For me, I've been working very hard with EPA, trying, to going to the EPA hearings, writing to our elected officials, talking to them about permits for air pollution, talking to them about the importance of changing risks for ozone, changing risks within some of these coal ash waste situations, and trying to do some education on these issues, because we're all downwind, whether or not we live in a relatively clean spot. We're all being impacted. You can take the blood out of almost anybody and measure it and find all kinds of chemicals in it that you wouldn't have found 20, 30 years ago. So we're all downwinders. We're all being impacted. And I think it's important for all of us to do something. And if coal were the only choice we had, we might say, well, we're willing to take some risks. But the fact is we have lots of other options out there. And increasingly, we're falling behind as a nation. Other nations, other parts of the world are moving ahead much faster on incorporating clean, renewable energy. And increasingly, even different states are, moving forward much faster. And I think these are things that, especially at a place like this university, where you have a lot of studies in sustainability studies, you really can begin to, I think, move forward. You can have a voice. You can talk to the administration to actually live up to and fulfill their own values and fulfill their own potential by moving forward on some of these issues. So, there's a lot of universities right now that are addressing the coal issue, are addressing the energy issue, are coming up with solutions. These are the places where the solutions are going to be made, and where a lot of these things are going to be tried and tested and advanced. And so I think it's important for you guys to get engaged with some of these challenges. And I think that's all I have to say. So actually, I would like to hear what you guys have to say, because I don't go to this school. Yeah? Yes? Because the grid isn't set up to take it. We're wasting a lot of energy, but we're also selling energy out of state. I mean, why are we doing that? That's a very good question. Why are we not using more wind? I think they're putting it up almost as fast as they can in some parts of the states, but they're not hooking it up always to the larger grid. There's some real problems. South Dakota produces a lot of wind too, but they can't get to the grid. So these are policy decisions. There have been a number of studies that show with the kind of wind that we have and the kind of solar that we have, we could pretty much match what's coming out of the coal companies now. It's political will that determines it. It's at 7 o'clock lecture on climate change, right? Yeah?
Amy brings some garbage. Like, if you studied any of those at all, and how that might help buffer the fact that we're burning a lot of coal, but at the same time we're also burning garbage.
It depends what's in the garbage.
Well, yeah.
Yeah. A lot of places are taking like landfill gas, it's methane, and burning that. And that it is essentially a form of energy that can be recuperated. And I think that's a great idea. Sometimes with burning garbage in general, it's also better. And they use it across Europe in different European countries to heat the hospitals or to run different operations. And it's better than not doing it. I think recycling as much as possible is better.
Like the fact that, like in New York City, what do you do with all that garbage? Like, as much of it to recycle as possible. But also they have power plants that are nearby within the city and everything else. So instead of like taking garbage outside the city or wherever, why not just send it to the plants to be burned as well and cut down on their coal import?
Yeah, that is one piece of the puzzle, and I think there are many of those pieces, and that is definitely one that people can use. The other thing is, how much consumption can the Earth actually sustain? You can only just use up and burn so much when you live on a finite planet, and so while that can be an interim solution, I don't see it as a long-term solution, but rather a piece of the puzzle, many pieces to the puzzle. Yeah.
What is clean coal?
A dirty lie. There are these efforts to capture the carbon and put it underground, carbon dioxide. It hasn't really been done in any demonstrable way. It's more a theory. It's very expensive, a mechanism. You have to pump the CO2 to an appropriate cavern or storage area. And that CO2 itself is very deadly if it were to break through. It's, I think, a very expensive, long-term, peculiar kind of solution when you have a lot cheaper, quicker, cleaner solutions at hand. And the idea of diverting a lot of money to develop an unproven system that it deals with a small piece of the puzzle. It doesn't deal with the mining issue. It doesn't deal with the water pollution issue. It doesn't deal with the mercury issue. It doesn't deal with the fact that it's increasingly energy intensive to get out amounts of coal. So it's a non-starter. It's not going to happen. It's a very expensive, very interesting, I think technologically interesting concept, but it's such a small piece for a very big amount of money that I don't see it going anywhere. I could be wrong, but I'll bet on it. What do you think about clean coal? Yeah.
Pretty much what you said.
Oh, okay. I want to know if I was. Yeah, it's very interesting how people come up with very complicated solutions when, like the lady in the back says, why aren't we, using more wind? And hopefully we will be. What's interesting is Iowa doesn't have a very good energy policy put together. A lot of other states have much clearer policies in place that call upon using greater amounts of renewable energies. Yeah, are you standing by the microphone?
Yes.
Okay.
I'd like your thoughts on a couple alternative technologies. One
Well, plug-in electrics are one of the things that a lot of people talk about as storage potential. When you're talking about how much storage capacity you have for these intermittent energy sources like wind and solar, there are a number of people talking about using plug-in hybrids as a form of storage, such that you could put into and take out of car batteries for some of your backup. And so I think it's an interesting solution, also because our batteries can store more than they need on any given day, and a smart grid system would have that kind of communication. I think parts of Europe are going with that kind of an approach. Of course, trains are better still. Or borrowed cars, where you don't have to everybody own a car, but you have a smaller number of cars per community because you borrow them. For those of you who've spent any time in Europe, you know you can go into some public garages and pick up a car. You use it for whatever you need it for, and you take it back. And then you can also take some of these cars to plug-in stations where they get their electric generator recharged or their battery recharged. As for biomass and coal, there are all kinds of biomass out there. And some biomass is just as dirty and difficult as coal, and some biomass is looking very promising. The algae production, the plant here in Iowa is ready to go commercial. The algae eats up the CO2, so it's a double whammy. You know, it gives you the energy and it's sucking up CO2. And that seems very promising. Some of the other biomass is very difficult to imagine us going for very long with very much biomass, with 7 billion people on a hungry planet with poor water resources. When you're talking about biomass, you also have to be talking about soil, food, and water, and making a calculus. And you also have to put a lot of energy in to get energy out, and the bang for the buck is not real great with a number of different biomass feedstock, but it varies. And so a lot of people talk about it as one of those transition technologies, but probably not a long-lasting technology, except maybe the algae. I think the algae is interesting. Do you do any of that here, that research in the algae for biomass or for energy? No? Yeah?
Thank you for your talk. I was wondering, we are all essentially renewable in the future, wind and solar, and probably the NHP geothermal would be reasonable options.
For Iowa, if you live on the coast, of course, you got wave and hydropower some places, yeah. Yeah,
So I'm just wondering if you might comment on your thoughts about the extent to which our future might be able to build high-capacity transmission throughout the country.
I'm not any kind of an expert on transmission, but I do know that there have been a lot of studies, one in North Carolina, one in Minnesota, one in Utah, clearly out in California, looking at the conversion of, or the confluence of these different intermittent resources, and how you can put them together with smart grids and efficiency. You can never overlook the role or the importance of efficiency either, but that because the wind is always blowing somewhere, and the studies that they've done in states that have decent amount of wind, like Iowa, like South Dakota, is that while the wind may not be blowing right here or right here, but 2 blocks down the wind is blowing. And if you get enough of a distributed source, you do get enough wind, you do get enough solar most of the time. Most people say for some time to come you would need maybe a little bit of gas in there for kick up if you all of a sudden had the total wind doldrums and a very cloudy day. But by and large, it tends to be, and this is where people have sat, months and days at a time measuring both solar intensity and wind intensity at multiple sites across a given state, that you do get up to, and can, with time, up to 96% coverage between the intermittent sources with a little bit of backup. And sometimes a little bit of backup has to come from another state. But with regard to wind, and most of the time we're actually wasting a lot of it. We're not able to use it. And so people are developing storage mechanisms for wind in underground caverns, much the way we already store natural gas, so that you get compressed air or you get a water hydrologic pump to work as those backup mechanisms. And so it does seem, from what people are doing and what they're doing in Germany, what they're doing in Malta, what they're doing in other parts of the world, that these systems really can work and will work. It's a matter of getting the political will to put it all together. Did you have other ideas?
I guess what I meant was, for example, you're not going to build wind in Georgia. You're not going to build solar in Georgia.
Why wouldn't you build solar in Georgia?
The solar resource is not good enough to make that an economic investment in Georgia. You have a very good solar resource in the southwest part of the United States and in the southeast. In fact, there's not very good renewable resource in the southeast.
Well, it was North Carolina study that I read. It's not that far from Georgia, is it?
So the point is you would build renewable resources in various parts of the country and then remove it to the southeast.
Yeah, yeah.
In the most economic scenario, that would require transmission. And I was just interested in your perspective about building out transmission. But it seems to me it would be a necessary requirement for a high renewable future.
Yeah,
And I
yeah.
know there's as much resistance towards building transmission as some people have towards coal, for example.
No, I don't disagree. And that was what I said to the first woman who asked about the wind, is that there is resistance to connecting up some of the best wind sources with transmission lines. And depends on who's producing the wind, whether or not the transmission lines get to them. But I think increasingly those barriers are going to break down. I mean, the kinds of flooding that we've had and the kinds of real weather challenges that we've had, and people are waking up to the fact that things are happening and that things need to be addressed, that they can't be ignored, that we can't stick our heads in the sand. And, we're going through a very tough time right now, but I think, the night is always darkest before the dawn, and I really do feel that we are a creative species. We want to survive. We can power up. We can do things. I mean, when you look at what happened with our factories in World War II, people can do it. It will be done. But people have to start talking about it. People have to start, talking to the head of the university and talking to their city councils and talking to their county boards and, just really pushing on it and talking about, I don't want to put the money into my health insurance for something that could be avoided by putting the money instead into a smart grid and a distributed system and a more appropriate transmission system.
And we haven't mentioned nuclear. What's your thought about that?
Very expensive, takes a long time to set it up. It has to go down when you have things like floods. Like I said, Fort Calhoun was down for months. It costs at least as much as any of these distributed kinds of issues, and then oftentimes more than twice as much. And we are building the equivalent of a nuclear power plant every year and a half or 2 years with just our increase in wind capacity and solar capacity. Why would we stop doing that and put all of our money into a very expensive system that produces forever waste? we have to come up with a way to deal with that waste for thousands of years. It doesn't go away. It needs to be in these big dry cask storages. If it's in the water, it's always at risk. And I think we would be very foolish to put massive amounts of money into that particular resource. We can do it cheaper, faster, cleaner with other mechanisms. All the ones we have now are going on, they're finding cracks, they're finding problems. They're still operating, but they're very old. And we would have to start up very fast with a whole lot of money to meet the energy needs that we have on a planet that's getting bigger in terms of population and demands every day. It's a complex issue. I don't think it's readily solved, but I think we can do it. And I think places like this university that have a high stress on sustainability and on engineering, this is the kind of place where it's going to happen.
Can I just add, though, if it wasn't for the Duane Arnold nuclear plant, then almost 100% of the electricity in Iowa would be from coal. So Duane Arnold is the largest energy source in Iowa that is reducing CO2 emissions. And that's true for nuclear power in the United States and in the world. And China and India, where I was 3 times in the last year, are building nuclear plants in 4 years.
And I've spent a lot of time in India as well. And
Fukushima, but no one was killed in Fukushima.
Not yet.
Were killed from the enormous earthquake
Yeah.
and the enormous tsunami.
Well, I didn't come to talk about nuclear. I know you teach it, and I know that's your...
I say that the wind energy and solar in the world is less than 1% and has been less than 1% over the last 30 years.
No, check your statistics. They're off.
No, I have the most recent statistics, and that percentage has not increased even though solar and wind turbines are being built. It's just that the total demand for electricity and energy in the world is growing because, as you said, we now have 7 billion people on the planet. And so, you have to consider nuclear power because nuclear power is the only base load electricity generator that does not produce CO2 emissions.
And you and I could argue this for a long time. It's not appropriate in this setting.
The most famous climate scientist of all has written in his recent book that nuclear power is the only solution to global warming. And so I think that there are many environmentalists who are climate scientists who think nuclear power is the only solution.
And ditto the opposite, So, I mean, we could line them up for sure, and we could argue this point for sure. And there's plenty of evidence that you can get basically to the same amounts.
The problem is when Germany decides to discontinue its nuclear plants, they are now replacing those nuclear plants with coal-fired plants. So Germany is only going to increase.
Thank you all for coming. I hope you have a good lecture over in the climate change discussion.